Good morning, everyone. In the previous lecture session, we had learned how to write symbolic microprograms for uh, these four instructions: add, branch, store, and exchange. Okay, and these were the common instructions which we learned uh, how to write the microprograms for it. The program that we had written was symbolic microprogram. Okay, we had also seen how to represent the same microprogram using the binary notation. So this was the binary microprogram of the micro instructions, which we had written in our microprogram. Okay, so now let us move on to the last topic of the chapter, which is design of control unit. You all remember how we performed the design of control unit in chapter number 5. Okay, if you had an instruction like M of AR to DR, if you were asked to design the control unit for memory, okay, what did you do? You identified what were the read and write, which were the instructions which were, suppose you are asked to find out the control logic for the read input of memory. So what did we do in that? We identified those instructions which were on the left hand side of our RTL statements. And for those RTL statements, whatever was our control function, we designed a control logic circuit for it and provided it to the read input of the memory. Okay, similarly, if you were asked to design the control logic for AR, what did we do? We identified those instructions which were loading some data into AR, which were incrementing the value of AR, and which were clearing the value of AR. So that was how we designed the control logic for different registers in our basic computer. Now here also we are going to do the same thing, but here let us see how to do that. Yes, just a minute. Now look at this figure. Here we are doing the same thing. Okay, suppose I want to design the control logic for AI. First of all, see what did we do in that? Do you remember the control organization of hardware circuit that we studied? We were I had a 3-bit opcode 1, 2, 3. We provided these 3 bits to a decoder, 3 cross 8 decoder, and it generated D0 to D7 for us. Okay. Similarly, here also to identify which instruction is it, we have 3 sets of 3 pools here, right? F1, F2 and F3. So for all F1, F2 and F3, what we are doing is we are using 3 cross 8 decoders. This will tell us which was the instruction from F1 pool. Like suppose if you look at F1 pool, 0 is for no operation, 001 was for add, similarly 100 for DR to AC, then 101 was DR to AR, 110 is PC to AR. So these are the instructions of F1 pool. We had studied this. I'll show you once again so that you can recall this. We had seen this table of instructions. Okay, so these are the instructions of F1. When I provide these 3 bits of F1 into a 3 cross 8 decoder, what will it do? It will we will be able to identify which of these instructions, clear AC, increment AC, DR to AC, DR to AR, PC to AR, which of these instructions are selected, okay, depending upon F1 input that is written in your microprogram. Now, suppose I want to identify, if I want to design the control logic for AR, okay, here I have 2 instructions, DR to AR and PC to AR, which are loading some content into AR. In the first instruction, when F1 is 101, DR is being loaded to AR, and in the second instruction where 110, PC is being loaded to AR. Okay, so now what we will do is, look at the figure here. I want to design the control logic for AR. So what we are doing is, look over here. To the load input of AR, what we are providing? We are providing 5 and 6 of F1. What was 5? DR to AR. What was 6? PC to AR. So either of these, if F1 has the value, either F1 has value 101 or value 110, in both these cases, we need to load AR. So what did we do? We connected these two instructions to the load of AR. If either of them is true, load the value of AR. Right? Then, apart from it, here we are using a multiplexer. Where will data into AR come from? Either PC or DR. Okay, when DR to AR is 1, this is my selection line. When DR to AR is 1, in that case, the first input would be selected. So whatever is the value of DR would be transferred to AR. And if DR to AR is 0, in that case, the value from PC will be entered into AR. So here what we are doing is, we are just identifying the instructions which are loading some value into AR, and accordingly we are providing those inputs to the load input of AR. Okay, similarly, if I want to identify the instructions which are changing the value of AC, okay, so which are the values that would change the value, which are the micro instructions that would change the value of AC? Suppose AND is a micro instruction. Okay, when I perform AND on any two numbers, the answer is going to be stored in AC. Similarly, when I perform add operation, when I perform DR to AC, DR to AC is what? It is loading the value of DR into AC. So all these instructions are changing the value of AC. So what we are doing is, for all these instructions, we are loading the content of AC. So similarly, you can you can design the control logic of any of the registers involved in your microprogram control organization. Okay, the only thing is, identify the instructions that are either loading value into a particular register, whether they are incrementing or clear. If I have CLRAC, what will I do? I'll connect that CLRAC to the clear input of AC. I'll connect the increment INCAC है हमारे पास. I have an instruction called clear AC. Let me show you here again. Okay, so if you have increment AC and increment PC. Here, increment AC is this one. So what will you do? You will connect F1 का third input 0, 1, 2, 3. So this pin you will connect to the increment pin of your AC register. This is your AC register. To your increment pin, you will be connecting this input. Similarly, if you want to clear AC, to your clear input, you will connect this one. So this is your clear pin of AC. This is your increment pin of AC. And you will be identifying which of the operations that add hai. Then you have this one, then you have or, you have subtraction, you have and, all these are changing the value of AC. So you'll be connecting all these to the load input of AC. So this is the same thing that you had done for chapter number 5, designing the control logic. So similarly, if you're asked to design the control logic of any of the register, what you need to do is, you need to identify those instructions that are either loading the value into that particular register. If I talk about DR, okay, so this one is incrementing DRs, INCDR. So what will I do? F2 ka 110, I'll be providing to the increment pin of DR. Then AC to DR and PC to DR, they are loading the values into DR. So what will I do? I'll connect them to the load input of DR. Is it simple? So this is all about designing the control unit of a microprogrammed control organization. Okay, so here only this figure explains how are the different register, how to design the control logic for different registers. This is for AR, this is for AC. So two examples are given over here, and you see that similarly you can design the control unit for any of the registers that are included in the organization. I hope it is clear to you.